If we pick and try to investigate any of the control on the page, we will see already 3 directives that reside on this node. Some of them we already know. The form control name directive is responsible for registering the form control instance in the form group of the form, and it's responsible for kind of linking the form control model with some native control. And something similar does also ng model if you use template-driven forms. Then we have a directive ng control status that is tracking the form control statuses like validity, if it's dirty or touch, and adds appropriate CSS classes to the node where this directive resides. And the third one is default value accessor. In this video, we will try to figure out what is the responsibility of value accessor, and we will focus on the theoretical part. So let's get started. From the previous videos, you should know that usually every form model like form control has a one-to-one relationship with a corresponding native control like input, text area, select, etc. We do it using appropriate directives like form control name if we use reactive forms, or ng model if we go with template-driven ones. But it is not enough just to establish a connection or relationship. For proper work, we should care about the state synchronization between them, right? Because I can set some value on the model side, it obviously should be reflected on the view side by assigning this new value to the value property of the input element, right? Otherwise, the user just will not see the new value in the input. However, it might also happen that the user changes the input value by typing a new one into the input element, and in this case, we should do the opposite operation and update the form control model instance to reflect these new changes. And yes, this time we should call setValue method with a special flag emit model to view change set to false, because we don't want to propagate the change to the view again, because this new value actually came from this view, right? And this synchronization of states is exactly the area the value accessor is responsible for. Now let's learn which exactly states synchronize the value accessor. Currently we have seen 2 of them. The value change from model to view, and the opposite one from view to model. Then we remember that usually when we move the focus from some input, we trigger a blur event, and in Angular forms, such control is considered to be touched. And we should also synchronize this state with our model and update it by calling an appropriate method. And the last state, which is optional by the way, is disabling state, because we can call the disable method on the form control model and it has to be reflected on the view side. So there are 4 states that value accessor synchronizes between form control model and native form control. But how exactly does it happen? Well, it happens by calling corresponding methods of value accessor, and those methods contain the actual logic of how should be updated the model or the native control like input. First, let's have a look at state synchronizations that go from the model to the view. Every time we set a new value to the model, there will be called the writeValue method of the value accessor, and the new value will be propagated as an argument for this function. Then, every time we disable or enable the control model, there will be called the setDisabledState method with a Boolean parameter that indicates if the control is disabled or not. The changes from the view to model are being done in slightly different ways. When the form control is being set up during the ng model or form control name directive initialization, the value accessor's register on change method is being called. It happens only once during the form control lifecycle. However, this method passes a special function as an argument to this function that contains the logic that updates the corresponding model value. The only thing you have to do is to call this function anytime when the user changes the value and propagate the new control value as an argument for this magic function. So in such a way, the model will be updated and the state will be synchronized. Pretty much similar happens for touch synchronization. There is also a dedicated method called register on touched, which is also called once during the initialization and provides some magical callback function that needs to be called every time when the native control is supposed to be touched, for instance on the blur JavaScript event. You might also ask, why would we need a separate abstraction for that? Couldn't we do this synchronization directly in the directive? Well, the thing is that besides the input control, there are many others that have different behavior and different API. For instance, if instead of the input we would have here some checkbox, we would need to update not the value property, but the checked one and trigger view to model synchronization not on input event, but on change one. If we did all this stuff directly in the directive, we would get a huge if-else tree for each control type implementation, which definitely violates a single responsibility design principle. But what is even worse, it would violate the open-closed design principle, which allows you to introduce completely new types of controls without modifying the ng model or form control name directive. Otherwise, we would be, restricted only by control types that are built into the framework. But excluding the value accessor, we can have an infinite number of value accessor implementations, which might be not necessarily an input, text area, or checkbox implementation, but it can be your own components that implement some unusual controls like rating pickers, different sliders, etc. The only thing that those value accessors should have in common is to implement an appropriate interface called control value accessor in order to be sure that all required methods are implemented properly. That's it. I hope the theoretical part was clear to you, and in the next video we'll have a look at how everything we just learned looks in the real code.